Hello, what's up? Walaan kayo, studying Math 21, no? I knew it. Anyway, so dito sa video na to, we are going to practice computing for limits of trigonometric functions, and we're also going to practice applying the squeeze theorem and the intermediate value theorem. Okay, so sounds good? Well, we have lots to talk about, so let's just get on right ahead. Okay, so we are starting with limits of trigonometric functions. For this, we have this very useful theorem for evaluating those kinds of limits. It is very useful. If you don't believe me, I'll show you how powerful it is sa examples. Okay, so just you wait. But let's be mindful of something here. Etong function f of x na nasa loob ng sine or ng cosine, it can be anything in this theorem as long as it is not equivalently equal to 0. And yung limit ng function f of x as x approaches a, it should be 0. Okay? So as long as we satisfy this, pwede natin gamitin tong results ng theorem. Okay? So let's try some examples. The first problem asks us to compute the limit of x squared plus x minus 2 over x minus 1 as x approaches 1. So yung existence nitong sign dito sa function na gusto nating i-evaluate, and also if you check, this is an indeterminate of the form 0 over 0. So these two facts tell us that maybe we can use this theorem. So this theorem has two versions, both involving sign. The first one has sign sa numerator, tapos the second one has sign sa denominator. Okay? So para maging useful siya sa atin, ang gagamitin natin is yung first version, which is kamukha nung problem natin. So ngayon meron na tayong idea what we can use, let us just understand kung ano yung expression sa loob ni sign. Okay? So what we can do is factor this out, so you'll get x minus 1 times x plus 2. And then just copy the denominator, which is x minus 1. Okay? And at this point, let me just make a short comment na in general, sine of a product, so for example, sine of alpha times beta, in general, this is not equal to sine of alpha times sine of beta. Okay? So itong numerator natin, it cannot be factored as a product of two signs. Okay? So just let it be. Kakopyahin lang natin siya. Huwag nyo na siyang i-simplify. Okay? Tapos, kung gusto natin gamitin tong theorem na to, yung expression sa loob ni sine, kakopyahin natin siya sa denominator natin. Okay? Pero sa loob ni sine, we have x minus 1 and x plus 2. Tapos sa denominator natin, we only have x minus 1. Okay? So, ang gagawin ko is, I will introduce an x plus 2 dito sa denominator natin, pero wala naman akong intention na baguhin yung original function kasi otherwise magbabago yung sagot. So, ang gagawin ko, I will also introduce x plus 2 sa numerator. Okay? Kasi kapag ginawa ko to, parang essentially nagmumultiply lang ako ng x plus 2 over x plus 2, which is just 1. Okay? So, pag nagmultiply ka ng 1 sa isang function, wala naman nagbabago sa function. Okay? So, from here, evaluate lang natin tong dalawang limits na to. So the first limit is just a direct application of the theorem. So this is just equal to 1. The next limit is just the limit of a polynomial. So just substitute x equals 1 and then you're good. So 1 plus 2. And then our final answer should be 3. Okay. Next. The next problem asks us to compute the limit of 2x times cosine of 2x times cosecant of 4x as x approaches 0. So, our function, yung gusto natin i-evaluate, it involves trigonometric functions in it. So, in order to know which result out of the 4 we can use in order to solve this problem, i-rewrite lang muna natin siya in terms of sines and cosines. So, we will get limit of 2x times cosine of 2x, and then cosecant is just 1 over sine, so we get sine of 4x down here. Okay? So, meron tayong sine of 4x sa denominator, so this tells us that we can use this theorem again, pero the second version naman. So, the version where sine is in the denominator. Okay? So, what we can do is, ihiwalay na natin yung gusto nating quote-unquote i-complete. So, meron akong sine of 4x dito. Tapos, i-write natin siya yung natira in another limit. So, I get 2x times cosine of 2x over here. Okay? So, in order to complete this, magdadagdag lang ako ng 4x sa numerator. Pero kapag nagdagdag ako ng 4x sa numerator, kailangan ko siyang bawiin sa denominator. So, isusulat ko naman siya dito sa second limit ko. Okay? Tapos, we start to evaluate. So, the first one gives us, so just a direct application of the theorem ulit. So, it gives you 1. Tapos, the next one, this is an indeterminate of the form 0 over 0. Pero we can cancel 2x and 4x, tas may matitirang 2 dito sa baba. Okay? So, this is actually just the limit of cosine of 2x over 2. Pero as x approaches 0, you get cosine 0, which is 1. So I just get 1/2. Okay? Next. So dito naman sa next problem, we have this complicated function. Tapos gusto natin kunin yung limit niya as x approaches 0 from the left. Okay? So already I can see some things I can work with. For example, 1 minus cosine of 5x, tapos sine of 2x. So, well, ililista ko muna yung results that we can use. So itong apat na to, para pwede natin siyang balik-balikan later on. Okay? So, pag ganito na medyo complicated yung function, ang gagawin natin, isa-isa lang. Okay? So, ang gagawin ko is, I will complete, so quote-unquote, complete sine 2x first. So, to complete that, just introduce 2x sa numerator. Tapos, leave your sine of 2x sa denominator. Okay? Pero since I introduced sine of 2x sa numerator, babawiin ko siya by introducing 1 over 2x or introducing 2x sa denominator. Okay? Ngayon, ang isusulat ko naman dito is yung natira dun sa original function. So, 1 minus cosine of 5x plus tangent of 3x, but let me just write that as sine of 3x over cosine of 3x. Okay? So, sines and cosines lang tayo para clear sa atin what we can use out of these four. Okay? So, ang pwede natin gawin, evaluate natin to. This just looks like letter B. So, this is just equal to 1. Tapos, multiplied with, lagay natin yung bracket. Ang gagawin ko, i-distribute ko yung 1 over 2x dito sa sum na to. Pero, in a little different manner. So, how will I do that? I-group ko yung 1 minus cosine 5x. Ihiwalay ko siya. Tapos, don't forget the 2x. Tapos, dito naman sa isang term, nandito yung sine 3x over cosine 3x. Okay? So, sine of 3x over, well, may 2x dito so don't forget, 2x of cosine times cosine of 3x. Okay? So, ba't ko ito ginawa? Kasi hinihiwalay ko yung 1 minus cosine of 5x para magamit ko si c. Tapos, hinihiwalay ko naman yung sine of 3x para magamit ko yung a. Okay? So, sinabi ko na gusto ko siyang gamitin. So, I will pair, for example, dito sa 1 minus cosine of 5x, I will pair this with 5x. Okay? Para magamit ko si c. Pero since nag-introduce ako ng 5x sa denominator, don't forget, nag-introduce kayo ng bago, so babawiin mo siya by introducing 5x sa numerator. Okay? Tapos copy nyo lang yung natira, which is 2x. Okay? Tapos dito, I'll just put brackets, no? So, put grouping symbols when you can para hindi ambiguous yung order ng operations. Okay? And then dito naman sa second term, iihiwalay ko yung sine of 3x, i-complete ko siya. So, dito, sine of 3x, I will pair it with 3x sa baba. Pero since nag-introduce ako ng 3x sa baba, mag-i-introduce ako ngayon ng 3x sa taas. Okay? So, meron akong 3x dito. Tapos, isusulat ko lang yung natira. So, ang natira ay 2x times cosine of 3x. Tapos, just close the bracket. Tapos, from here, we're almost done. You just need to evaluate. So, dito sa first limit, gagamitin ko lang si c. Pero c tells us that this is equal to 0. Tapos, yung second limit, this is an indeterminate of the form 0 over 0. So, you just have to cancel the excess. And then, you're left with 5 over 2. Okay? Tapos, don't forget your brackets when you can. Tapos, plus. This one naman, this is, this looks like letter A. So, this is just equal to 1. And finally, yung last limit, again, 0 over 0 to. But you just need to cancel the excess. So, mawawala to. So, you get 3 over 2 times cosine of 0. But cosine of 0 is just 1. So, you get 3 over 2. Okay? So, from here, you get 0 plus 3 halves. So, the sum is 3/2, which is our final answer. Okay, next. Alright, so sa next example naman, I have this. So it's a little bit different in the sense na merong exponent this time, pero wag niyo muna siyang pansinin. Ang gagawin natin is to write this function in terms of sines and cosines first. So since tangent is just sine over cosine, I can write this as sine cube, so diretso na, sine cube of 3x over, so may 3x cube ka dito, and then times cosine cube of 3x. Okay? So, ang nakikita ko dito na pwede kong gamitan ng results before is this sine cube of 3x. So, if you can't remember it, it's this one. So, ang gagamitin natin is the first one kasi sine natin ay nasa taas. Okay? Tapos ngayon, let us deal with the exponent. But first pala, the numerator, para hindi siya mahirap i-visualize, you can express it as bracket sine of 3x tapos cubed. Diba same lang naman sila? So para siyang ganito, tas kopyahin nyo lang to. 3x cubed times cosine cube of 3x. Okay? So in a sense, para akong may tatlong sine of 3x. So meron akong tatlong sine of 3x na gusto kong quote-unquote i-complete. Okay? So meron akong tatlong sine of 3x. Tapos gusto ko sila i-complete. Pero ang kailangan ko i-complete sa ang kailangan ko i-pair sa sine of 3x is just 3x. Pero since I have 3 of them, just cube this one. Okay? So I will introduce quantity 3x cubed. And then since I introduced this value, kailangan ko siyang bawiin. So ilalagay ko lang siya sa numerator. And then write the remaining terms. So meron ako ditong 3x cubed times cosine cube of 3x. Okay? And now, ready na tayo mag-evaluate. So, this part, this is just, well, you can express this as, kung hindi pa rin kayo convinced, you can express this as limit ng sine of 3x over 3x, tapos cubed, tapos this one, so limit ng 3x cubed, or actually, isimplify na natin siya, ang 3x, quantity 3x cubed, this is just 27x cubed over 3x cubed cosine cube 3x. Okay? This part, this is just 1, tapos raised to 3, so meron kang 1 raised to 3, times, this one is 0 over 0, so just cancel the x cubes, and then you'll get 27 over 3 times cosine cube of 3x, itong cosine cube of 3x magiging cosine cube of 0, so 1 lang yun. So you get 27 over 3, which is just 9. Okay? So you have the final answer is 9. Next. Alright, so dito sa next problem, we have this function, x times tangent of 5x, all over sine squared of 2x, and then we want to take its limit as x approaches 0. Okay? So ano ulit yung gagawin natin when we are presented with this kind of problem? So tama. Susulat natin siya in terms of sines and cosines. So yung tangent lang naman yung kailangan natin i-expand, right? So sine over cosine lang naman yun. And also, multiplication lang naman yung operations dito. So ang mangyayari dito, yung sine of 5x, may iwan lang siya sa numerator. Tapos yung cosine of 5x, malalaglag sa denominator. Okay? Tapos copy mo lang si sine squared of 2x. Okay? And then before we do anything different, i-rewrite lang muna natin to katulad nung ginawa natin before. So, okay na ako with x times sine of 5x. Clear naman siya sa akin. Medyo straightforward na. Tapos, okay din ako with cosine of 5x. That's clear to me. Pero this one, isusulat ko siya as bracket sine of 2x. Tapos, square dito. Okay? And then, I can already see sa two things that I can work with. Well, meron akong sine of 5x sa denominator. I can complete that. Meron akong dalawang sine of 2x sa denominator, I can also complete that. Okay? So here is the theorem we're going to be using. Okay? Gagamitin natin both A and B. Okay, so since fifth problem na to, pwede na siguro natin tong, i-complete both of them in one line. So ang gagawin ko, isa-isa lang. So una ko nakita ay sine of 5x, so i-complete ko muna yon. So to complete that, I will pair it with 5x. Sa denominator. Okay? Pero since nag-introduce ako ng 5x sa denominator, kailangan ko mag-introduce ng 5x sa numerator. Okay? Pero I'll do that later. Just don't forget na may kailangan kayong bawiin na 5x. Okay? So, ang gagawin ko next, i-complete ko naman tong sine of 2x sa baba na dalawa. Okay? Pero since meron akong dalawang sine of 2x, kailangan ko ng 2x na dalawa rin. Okay? So, that is what I will pair with sine of 2x squared. Okay? Tapos yung last limit, andito yung mga, well, sorry for the term, pero andito yung mga natira na terms. So, meron ka ditong cosine 5x sa baba, tapos x sa numerator. Okay? Tapos, don't forget, kaya siya naka-green para hindi nyo makalimutan. So, may introduce kang 5x sa denominator, kailangan mo siyang bawiin sa numerator. Nag-introduce ka ng 2x squared sa numerator, kailangan mo siyang bawiin sa denominator naman. Okay? So, meron kang 2x squared here. Okay? And then from here, let's evaluate. So, the first limit is just, using letter A, this is just 1. The second limit is just letter B used twice. So, meron ka ditong 1 squared. And then the third limit is actually an indeterminate of the form 0 over 0. So, you have to cancel the x squareds. Tapos, just, pwede nyo i-expand to para hindi nakakalito ha. So, ito is just 4x squared. Okay? So, cancel 2x sa numerator, tapos 2x sa denominator. And then, you get 5 over 4 times cosine 0. But cosine 0 is just 1, so you get 5 over 4. Okay? So, the final answer is 5 over 4. Okay. Next. Okay, so for the last problem of the sort, gusto natin kunin yung limit ng x times the quantity 1 minus cosine of 1 over x as x approaches negative infinity. Okay? So since pang-anim na problem na to, you can probably guess what the answer is. And you're probably guessing that it is 0. So actually, you're correct. Okay? So it is 0. Pero bakit? Well, gagamitin pa rin natin tong theorem na to, in particular letter C. Tapos, the reason behind it is the original function that we want to evaluate, we can actually rewrite it as 1 minus cosine of 1 over x all over 1 over x. Okay? Tapos, baka first time natin makakita ng rational function sa loob ng cosine. But that would be no problem kasi dito sa theorem, ang kailangan lang naman mangyari, the function inside, so 1 over x, it should go to 0 as x approaches negative infinity. Okay? But that's true, di ba? So 1 over x, it goes to 0 as x approaches negative infinity. Okay? So from this point, gagamitin nyo lang yung theorem, which is letter C, tapos you can conclude na the limit is actually 0. Okay? So this would be our first solution. Dito naman sa second solution, if you're not convinced na yung original function, you can rewrite it in this manner, gamitin natin yung ginagamit natin before, okay? So, we proceed as we did before. So, ano bang ginagawa natin before? So, pag nakakita tayo ng 1 minus cosine, kino-complete natin siya, di ba? So, meron kang 1 minus cosine of 1 over x. Kino-complete natin siya by introducing 1 over x sa denominator, okay? Tapos, since we introduced 1 over x sa denominator, dito sa second limit natin, which contains the leftovers, so x, i-introduce naman natin yung 1 over x sa numerator. Okay? So you have this one. And then from here, just evaluate. So the first limit is equal to, well, gagamitin lang natin si c. This should be equal to 0. And then the second limit is just taking the limit of x times 1 over x, which is just 1. Pero ang limit ng constant is the constant itself. So the limit is 1. Okay? So from here, the answer should still be 0. Okay? Before we move on to the next problem, let's have a quick recall of squeeze theorem. So, yeah, it looks kind of scary, but it actually helps if you can explain it in your own words. It helps you understand it better and remember it better. So I'm going to tell you my interpretation. So basically, we need to satisfy two things to get to the conclusion. Ito yung two things na yun, yung 1 and 2. And our end goal is to get the limit of g as x approaches a. Okay? So to get there, we would first need two functions. One above g, which we will call h, and one below g, which we will call f. So basically, we're looking for functions that bound g within the interval. Okay? So f is geometrically below g kasi algebraically its values are smaller or equal to the values of g within the interval. Yung h naman, it is geometrically above g kasi its values algebraically are greater than or equal to the values of g within this interval. Okay? Ngayon, after we get these two functions, we compute for their limits as x approaches a. Ito yung number 2. Okay? If their limits turn out to be equal, call this limit L, then because of the first assumption, they're actually squeezing g and forcing the limit of g to be equal to L as well. Okay? So we get the conclusion. So this is how I explain squeeze theorem. Try explaining it in your own words, and let's try some examples. Bam! Over here is the next example. We have the function sin x plus 3 cosine x all over x, tapos gusto natin kunin yung limit as x approaches positive infinity. Okay? So kung hindi sinabi sa atin na gagamitan to na squeeze theorem, since kakagaling lang natin from evaluating trigonometric functions using a theorem, you probably might be thinking na this part, so sin x over x, this is equal to 1. Okay? So it should be equal to 1 based on the theorem, provided na yung function inside of sin, which is x, it goes to 0 as x approach whatever it is meant to approach. So as x approaches positive infinity. Okay? But you already know by looking at this na this is wrong. Kasi saan ba talaga siya pupunta? Sa 0 ba o sa positive infinity? Okay? So in this case, yung premise or yung hypothesis, it fails, so we can't use that result anymore. Okay? So usually, if we can't use that result anymore, tapos we have trigonometric functions in the function that we want to evaluate, usually squeeze theorem yung sasalo sa atin. Okay? So ngayon, kung gusto natin gamitin yung squeeze theorem, we have two steps. So the first step is to look for two functions, one function above and one function below. Okay? So in essence, binabound natin tong given na function. So, well, this is a complicated looking function, pero huwag kayong matakot. Kasi ang gagawin natin, we're gonna look for a simple component that we know how to bound. So for example, we know that sin of x, ang range niya ay from negative 1 to 1 lang. So that's okay. And this is actually true for all real numbers x. Okay? So okay na tong part na to ish, and then we go to this part kasi may cosine tayo. So meron tayong cosine x, and we know that its range is the same as sines. So meron kang negative 1 to 1. Okay? Pero dito sa function natin, it's not cosine x, it's 3 cosine x. Okay? So ang gagawin natin, we will get 3 cosine x by multiplying 3 dito sa middle. Pero pag nag-multiply ka ng 3 sa middle, i-multiply mo rin siya sa left and sa right. Okay? Tapos pala, walang fear of switching inequalities. So hindi ito magbabago kasi ang minultiply natin ay positive integer lang naman. Okay? So you get to keep this inequality less than or equal to. Okay? So from here, we've done enough preparations to bound the numerator. So ang numerator is sin x plus 3 cosine x, diba? If you want to get the smallest value of this function, just look at the smallest value of sin x, tapos add it to the smallest value of 3 cosine x, and then you'll get negative 4. Okay? To get naman the highest value, it's the same thing. Look for the highest value of sin x, tapos add it to the highest value of 3 cosine x, and then you should get 4 here. Okay? Pero hindi naman ito yung function talaga na gusto natin na i-bound, diba? Ang gusto natin, this one, yung original function. Pero how do you get that? Just multiply 1 over x. So here, I get the original function. Tapos sa left, I get negative 4 over x. And then sa right, I get 4 over x. Okay? Pero anong inequality symbol ang susulat ko dito? Well, yung x nyo, it goes to positive infinity. So sure kayo na it's trending on, well, big values pero positive ones. Okay? So walang fear na yung x ay maging negative. So you get to keep your inequality symbol. Okay? Hindi naman siya magiging negative eh. So, kung positive integer lang yan or positive number, you get to keep the inequality symbol. Okay? Thus, from here, if you refer to the statement of the theorem, this function here, negative 4 over x, this is actually your f of x. Tapos, this is your original function na tinawag na g of x dun sa theorem. And then, this is your function above, which is h of x. Okay? So, pwede na tayo mag-proceed sa next step, which is taking the limit of f and h as x approaches positive infinity. Okay? So we hope and pray na equal yon, kasi kung hindi yon equal, we have to find new bounds. Okay? So ang bound naman ng g, hindi naman siya unique. So you can find another ones. Okay? So let's take the limit. Sana equal. So ang limit ng f as x approaches positive infinity, well, ang f naman, this is just negative 4 over x. So what happens? Take a look at the numerator. It remains constant. Negative 4 pa rin yan. Yung denominator increases without bound. So what does it do to the whole fraction? The whole fraction goes smaller and smaller. Okay? So it approaches 0. And then dun naman sa h, as x approaches positive infinity, well, si h, it's just 4 over x, diba? Nakuha natin from above. And then here, it's almost the same. Ang mangyayari dito, the numerator stays the same, which is 4. Tapos the denominator increases without bound. So ang nangyayari sa buong fraction, it goes smaller and smaller, and eventually, it approaches 0. Okay? So ngayon, yay! Parehas yung limit na nakuha natin, so equal sila. So what can we say about the limit of g? So yung g, ginagamit ko lang in relation to the statement. Pero yung g talaga is the actual function we wish to evaluate. So ano mangyayari dito? Nag-expect ako ng sagot, pero so this is actually equal to 0. Okay? But why? Because of squeeze theorem. Okay. Next. Okay, so for this example, our function is 2x cubed plus 1 plus 5 cosine x all over 3x cubed. Tapos you want to take the limit as x approaches negative infinity naman. Okay? So let's just get right into it. To use squeeze theorem, there are two steps. The first step being we should bound the function that we wish to get the limit of. Okay? So again, this is pretty complicated looking, pero there's no need to worry kasi magsa-start tayo with something we know. So we know na for any real value, for any real number x, yung cosine x, it is bounded by negative 1 and 1. Okay? So you just have to take a look at the range. Pero in our function, meron tayong 5 cosine x. So to get 5 cosine x, just multiply 5 to all sides of the equation, and you should get negative 5 sa left, tapos 5 sa right. Okay? Tapos we get to keep the inequality symbol, less than or equal to, kasi 5 is just positive. Okay? And then next, our goal is to get the numerator, tas eventually the whole function. So to get the numerator, what do we do? Well, to get the numerator, just add 2x cubed plus 1. Kasi it is what it is, wala tayong masasabi sa 2x cubed plus 1. So just add it as it is. Okay? Pero pag nag-add ka ng 2x cubed plus 1 sa middle, you add 2x cubed plus 1 sa left to get 2x cubed minus 4. Okay? Tapos you also add 2x cubed sa right to get 2x cubed plus 6. Okay? And then we're nearly there. To get this function here, just divide all sides by 3x cubed. Okay? So sa middle, I should get 2x cubed plus 1 plus 5 cosine x all over 3x cubed. Tapos sa left, I should get 2x cubed minus 4 all over 3x cubed. And finally, sa right, I should get 2x cubed plus 6 all over 3x cubed. Okay? Ngayon, my question is, anong inequality symbol ang isusulat ko dito? Do I get to keep less than or equal to, or do I have to switch to greater than or equal to? So the answer is, I have to switch to greater than or equal to. Bakit? Kasi this time, yung x natin, it goes to negative infinity. Okay? So it takes negative values. So para nung nag-introduce ako dito ng 1 over 3x cubed, para akong nagmumultiply ng negative values. Okay? So I really have to switch. So this time, if you refer to the statement of squeeze theorem, eto na ngayon yung f ko. This one is my g. Tapos this one is my h. Okay? And then the last and final step, we take the limits of f and h as x approaches negative infinity, and then hope and pray na equal sila. Okay? So ano bang limit ng f as x approaches negative infinity? Well, si f ay, what is it? 2x cubed plus 6 over 3x cubed, diba? Tapos, if you plug in a negative infinity, actually you'll get an indeterminate of the form infinity over infinity. Tapos, remember, ano ginagawa natin dito? Kapag infinity over infinity, di ba we're introducing something? We're multiplying something actually. Okay? So, we're multiplying 1 over x raised to the degree of the denominator. So, meron ka ditong 1 over x cubed. Pero if you introduce something sa numerator, babawiin mo siya sa denominator. So, just multiply 1 over x cubed sa denominator then. Okay? And then from here, do the product operation. So, you'll get, distribute nyo lang. So, you'll get 2 plus 6 over x cubed over this, sa denominator naman, you'll get 3. Okay? And then just remember, as x approaches negative infinity, yung 6 over x cubed, it approaches 0. So, ang limit na to, this is actually just 2/3. Okay? And then, next, we'll take the limit of h as x approaches negative infinity. So, it's almost the same. Magkamukha sila actually, di ba? This time naman, I get 2x cubed minus 4 over 3x cubed. Okay? Pero if you plug in, or if you try putting negative infinity sa x, you still get infinity over infinity, which is indeterminate ulit. Tapos, same technique. Okay? So, to evaluate this limit, copy nyo lang yung h, so 2x cubed minus 4 over 3x cubed. Tapos, magmumultiply ako ng 1 over x raised to the degree of the denominator, which is 3 ulit, over 1 over x cubed. Okay? And then, simplify. So, if we simplify this, I get 2 minus 4 over x cubed over 3. Okay? So, again, this part, so 4 over x cubed, it goes to 0 as x approaches negative infinity. So, here you get 2 over 3. Okay? So, yay! Kasi, yung limit ni f tsaka limit ni h, they are equal. So, wala tayong magiging problema. We can apply squeeze theorem. Okay? So, by squeeze theorem, what can we say? By squeeze theorem, the limit of g, which is squeezed by f and h, so this limit as x approaches negative infinity, which is, well, yung g naman talaga yung actual function na gusto nating i-evaluate or kuhanan ng limit. What is its limit? So the limit is equal lang sa limit ng f tsaka ni h at x as x approaches negative infinity, which is 2/3. Okay? Before we proceed to the next problem, let's have a brief recall of the intermediate value theorem. So it would help if you would illustrate it. Okay? So here, we would need a continuous function sa interval a to b. So for example, it maybe looks like this. So what IVT says is that every value between f of a and f of b, every value is accounted for. So by accounted for, I mean, for every value between f of a and f of b, so for example, k, there is a corresponding x-coordinate. Okay? Ngayon, IVT is usually used to answer the question of, does your function attain this specific value? So you might wonder, sino ba nagtatanong nun? Baka naman wala. Okay? But, well, for one, mathematicians, but you know, functions model things in real life, so real-life scenarios. And this question arises and is asked more than we realize. Okay? So if you are presented with that problem, does your function f attain the value k over an interval I? So for example, itong function f na to, does it attain k over this interval? IVT says that we simply have to check if f is continuous doon sa interval I, and then if we can find numbers a and b, itong a and b na to, on the interval I, so that k is between f of a and f of b. So kind of like this. Okay? Kasi diba, this would be my f of b, and this would be my f of a. Okay? So IVT says that if you can do that, then you can confidently say na yes, f does attain k in the interval I. Okay? So some pretty powerful stuff. Let's see it in action. Boom. Okay, so for problem 9, we want to show that the function cosine x minus x, which we will call f, has at least one zero between x equals 0 and x equals pi. Okay? If we rephrase that, we're actually looking for a c between 0 and pi so that f of c is equal to 0. Or in other words, we're asking if the function f attains 0 when you take your x between 0 to pi. Okay? So pag ganito yung mga tanungan, you are given a function tapos you're being asked if that function attains a specific value, the intermediate value theorem can help you out. Okay? So ang intermediate value theorem, like any other theorem, you have to show na yung inaaral natin is it satisfies the assumptions of the theorem in order to get the advertised results. Okay? So for IVT, we have two assumptions. Number one, continuity at the interval concerned, so 0 to pi. Okay? Pero how do we show this? So, gusto natin continuity ng function na inaaral natin. So, f, di ba? At this interval. But we all know na, well, by looking at the graph of cosine, we know that it is continuous in R. Okay? Tapos si x naman as a polynomial, continuous siya sa R. So, continuous everywhere. So, kung itong dalawang functions na to ay continuous, we have a theorem na if you have two continuous things, its sum and its difference are continuous as well. So, in particular, interesado tayo sa cosine x minus x kasi yun yung f of x natin. Okay? So, this is also continuous in R. Therefore, since continuous siya sa R, syempre even more so, f of x is continuous at 0 to pi. Okay? So, okay na yung first assumption. Satisfied na yan. Kailangan ko na lang i-satisfy yung second assumption. So, sa second assumption, we are looking for two values. Tawagin natin a and b. Tapos, yung a and b natin, hinahanap natin siya between 0 and pi. Okay? So, we're looking for two numbers so that yung value na gusto nating ma-attain ni f, which is 0, pagigitnaan siya ng f of a at saka f of b. Okay? So, usually, pag ganito, we usually use the endpoint. So, we use 0 and pi. Pero if ever hindi siya mag-work, so if ever hindi natin makuha itong inequality na to, don't worry kasi dito sa set na to, you can take any other points. Basta within this set. Okay? So, for simplicity, try natin gamitin yung 0 and pi. Tapos, let's hope na gagana na siya. Okay? So, try natin ipasok si 0 kay f. What do I get? Well, I get cosine 0 minus 0. But cosine 0 is just 1, so I get 1 minus 0, which is 1, and this is greater than 0. Okay? So I'm halfway done kasi f of 0 is already greater than 0. So parang yung b ko, yun yung 0. Okay? So let's just hope na f of pi is less than 0, tapos we're done. Okay? Pag pinasok ko naman si pi kay f, I get cosine pi minus pi. But cosine pi is just negative 1, tapos magsusubtract pa ako ng pi. So this is obviously a value that is less than 0. Okay? So yun na yun. From these two lines, I can say na 0 is pinagigitnaan ng f of pi tapos f of 0. Okay? Which is exactly what I want to show. So okay na yung second assumption. So by IVT, we can proceed to the result. By IVT, there is a number, tawagin nating c, between 0 and pi. So, in-exclude ko na yung 0 and pi kasi I know from this na pag pinasok ko si 0 kay f, I get something greater than 0. Kapag pinasok ko si pi kay f, I get something less than 0. So, it won't be 0. Okay? So, there is a number c between 0 and pi so that f of c equals 0. Okay? Which is exactly what we want to show. Okay? Next. Okay, so for our last problem, finally, we have a polynomial g of x equal to x to the fourth minus 7x squared plus x plus 4. Tapos gusto nating i-show na it has at least two zeros. Okay? So this is a slightly different example than the one we had before. Pero don't worry kasi, well, kaya natin to. Okay? So ano ba muna ang itsura ng isang function that has at least two zeros? Okay? So geometrically, it kind of looks like this. So, it passes through the x-axis twice. Bakit? Kasi, well, if you have 1, 0, it means na geometrically, your curve passes through the x-axis. Okay? So, kung gusto mo ng at least 2 zeros, it must pass the x-axis at least twice. Okay? So, that means at least 2 points of intersection. Okay? So, ito and ito. Okay. By the way, yung x-coordinates ng points of intersection, yun yung tinatawag natin na zeros ni g of x. Okay? So your g of x can look like this. So from positive, dadaan sa 0, tapos negative, dadaan sa 0, tapos positive. Or it can look something like this. Okay? So from negative, dadaan siya sa, magkakaroon ka ng 0 dito, tapos positive, and then 0 na naman, tapos negative. Okay? So, in other words, there should be at least two change of signs. So, positive, positive, or negative, negative. Okay? So, ngayon, kung gusto natin ng at least two zeros, this problem translates to finding two intervals. So, this first interval and second interval, so that your G has a zero in each of those intervals. Okay? Pero, kung naghahanap ka ng zero, essentially you're asking if your G can attain zero. Diba? Pero does that ring a bell? It should ring a bell, diba? Kasi if you have a function, tapos if you're being asked if your function attains a specific value, in this case 0, diba ang useful sa atin na theorem is intermediate value theorem? Okay? So, ang gagamitin natin dito ay IVT, tas we're going to be using it twice. So, one for this interval and one for this interval. Okay? Ngayon, kung gagamit tayo ng IVT, kailangan natin ng continuity. Okay? So, nasabi ko na, di ba, nagagamit tayo ng IVT twice. Pero, all throughout, ang aaralin natin ay yung function G. So, we only need to show continuity once. Okay? Now, G is a polynomial. Clearly, it is a polynomial. Pero, what do we know about polynomials? Ang polynomials, they are continuous. Where? They are continuous everywhere. So, continuous on or in R. Okay? So, okay na tayo sa continuity. We just need to find, well, yung second assumption ng IVT. So, ang second assumption ng IVT, dito na magkakatalo between the intervals. So, di ba sa second assumption, we're looking for two values. So, A and B. Tawagin natin A and B. So, yung first two values, hanapin natin sa first interval. So, for example, kung ito yung graph ni G, ito yung I1 ko. Tapos, hinahanap natin tong values na to so that they satisfy an inequality. So, yung inequality na yon is, so ano ba yung value na gusto ko ma-attain ni G? Diba? 0. So, dapat pagitnaan siya ng G of A and G of B. Ganun lang. Okay? So, if you have 1 tapos 2.1, you can already use IVT on G over the interval I1. Okay? Pero gusto natin two intervals, so I'm going to need a 2.2. So, hahanap pa ako ng two other numbers, C and D. This time sa second interval. So, tawagin natin tong I2 so that yung value na gusto nating ma-attain ni G, which is 0, pagigitnaan siya ng G of C and G of D. Okay? So, ngayon, wala tayong restriction, hindi pa natin alam kung ano si I1 tsaka si I2, hahanapin pa lang natin. So, basically, wala tayong restriction on what numbers we can plug in sa G. Okay? But no worries kasi continuous naman siya sa R. So, we're gonna be working, fair game yung lahat ng real numbers. Okay? Pero we can choose numbers smartly. Well, in a sense, we can choose it smartly. Kasi, if you take big numbers, you will get big numbers as outputs of functions. Okay? So, hindi siya practical. Kasi yung computation nyo magiging mahirap. Okay? So, ang gagawin natin, we're going to be taking small numbers. Okay? So, ang gagawin ko, I will start with 0. So, ano bang mangyayari if I plug in 0 kay G? Well, I get 0 plus, minus 0 plus 0 plus 4. Okay? So, easy. I get 4, which is greater than 0. Okay? So, if only there is a change of sign somewhere, I will be good. Okay? So, try naman natin another small number, tas integer din. So, 1. Iniiwasan ko yung rational numbers kasi mas mahirap mag-add and mag-subtract. Okay? Feeling ko kayo rin naman mahirapan. Okay? So, integers muna tayo. So, magkakaroon ako dito ng 1 raised to 4 minus 7 times 1 squared plus 1 plus 4. Okay? So, here I will get, 1 plus negative 7 plus 1 plus 4, which is negative 1, which is less than 0. So, may change in sign tayo. Okay? So, from positive, we go to negative. Okay? And then to sum it up, meron tayong makukuha information dito that 0 is, well, pinagigitnaan siya ng g of 1 and g of 0. Okay? So we can take our first interval I1 to be the interval from 0 to 1. Okay? So ngayon, kailangan na lang natin maghanap ng isa pang change in sign. So try natin naman ipasok si 2 kay g. Ano ba makukuha ko? So I get 2 raised to 4 minus 7 times 2 raised to 2 plus 2 plus 4. And here I get 16 plus negative 28 plus 2 plus 4. Ano bang sum nito? So the first one, negative 12 plus 6. So I get negative 6. Okay? So walang change in sign, negative, negative pa rin. Okay? So, you can continue with plugging in 3 kay g, pero I will stop here kasi nahihirapan na ako mag-add ng big numbers. So, ang gagawin ko, try ko naman sa other side. So, sa negative side naman. Okay? So, try ko i-plug in si g of negative 1, tas ano kayang mangyayari? Well, I get negative 1 raised to 4. Oops. Mukha siyang 9. Raised to 4 minus 7 times negative 1 squared plus negative 1 plus 4. So, ano ba to? What do I get? Negative 1 plus, 1 lang pala. Kasi naka-raise to 4. So, I get 1 plus negative 7 plus negative 1 plus 4. And this is equal to negative 2, right? Yeah, negative 3. Okay. So, ang negative 3 ay less than 0, so meron tayong change of sign. So, negative, positive, negative. Okay? So, from these two, makukuha nyo na si 0 ay pinagigitnaan ni g of negative 1 and g of 0. So, I can take my second interval to be the interval from negative 1 to 0. Okay? Again, may change in sign. So, negative, from negative naging positive, tapos from positive naging negative. So, it shows me na merong dalawang zeros. Okay? So, to tie the knot, sulat na lang natin yung conclusion na by IVT, we can find two numbers. So, there exist two numbers. Ano bang magandang letter na hindi ko pa nagagamit? There exist two numbers, parang hindi nakakalito, N1 and N2 na lang. So, N1 in the first interval, which is, N1 in 0 to 1 sa first interval, and N2 sa second interval, excluding yung negative 1 tsaka 0, so excluding endpoints, so that my g of N1 is equal to 0, and my g of N2 is also equal to 0. Okay? And this is what we would like to see. So, meron kang at least 2 zeros kay G. So, yun na yun. We're done.